In this video, we are going to discuss AC generator. We have permanent magnet here, north and south. And then we have two slip rings. Okay, two slip rings. Okay, slip rings. Okay, let's say this is slip ring 1 and this is slip ring 2. Okay, now we have coil. Let me show you the coil. Okay, this is the first case. Okay, we have a coil. This is A, B, C, D. Okay, look at the connection over here. You can see that the coil, the end of the coil here is connected to S1 and the end of the coil here is connected to S2. Okay, please look carefully. Now, AC generator, we have learned before that generator changes from kinetic energy to electric energy. This means that you are the one that rotate the coil. Okay, now in this case we rotate the coil ABCD in a clockwise direction. So what happens is AB will move upward and CD move downward. This is the clockwise direction that we are going to do. Okay, now look at the right hand Fleming rule. Okay, look at right hand Fleming rule. Now let's say that we have the direction is upward. Okay, the direction is upward. You can see the direction is upward. The force shown by the thumb. Here's the direction of the coil upward for AB, and then here is the south. Okay, this is direction of the south, so this is direction of current. So from here we know that current flow in this direction. Okay, current flow in this direction, and then it goes back here. Okay, then you can apply right hand Fleming rule again. This is pointing at the south. Okay, and then this is the force because we rotate in a clockwise direction, so the middle finger shows direction of current, so that's why the current is here. So current will flow. You can see that the current flows toward S2, so current flow in this direction, and then the deflection of the galvanometer is to the left. Okay, initially it is 0 because 0 is vertical position like this. So when current flows in this direction, it will be deflected to the left, and then it goes back to the carbon brush and then to S2. You can see that current will flow back to the coil to make a complete circuit. Okay, in this case you can see AB here, so we can look here. This is AB, this is A, and this is B. So we can say that AB moved outward like this, just like this one. Okay, when it moves upward, it will cut the magnetic field. So the rate of change of magnetic field is maximum in this case, and that is why we have the maximum induced current in this case. Okay, this is the first situation. Okay, and then we will try to learn about what happens next. Okay, now I'm going to the next slide. We have learned that AB move upward. Now you can see that AB has been inclined. You can see the coil here has been inclined a little bit, like 45 degree. Okay, so what happens is AB, this AB actually move in this direction, and CD move in this direction. Okay, it moves diagonally. So in this case, it does not cut very much magnetic field. The rate of change of magnetic field is less than previous position. That is why the amount of induced current will be less. So it is somewhere here, because it has reduced. The induced current has reduced because it cuts magnetic field less than the previous position. Okay, now remember, we move it, we turn it in clockwise direction, and the next thing happens is it will be in this position. Okay, AB and CD, the coil here is already in vertical position. So in this case, you can see that the motion of AB is horizontal and to the right, and CD horizontal to the left. So in this case, you can see AB is moving parallel to the magnetic field, so it doesn't cut the magnetic field, so there is no induced current. Okay, there is no induced current. And for CD also, there is no induced current. So in this case, the galvanometer will be 0. Okay, this is 0. When it is 0, it is vertical. The pointer will be vertical. That is the position for 0 voltage or current, 0 induced current for galvanometer. So what happens next? Okay, what happens next is this. Okay, you can see it yourself. Now AB is already on the right hand side of the generator. So in this case, now you can apply this again. Okay, you can apply this again. You will find that the direction of current is like this. Okay, you can apply this yourself. Now this is the new direction. Actually, the direction is the same as the first one, but the difference is you can see that current flows into S1 because the coil is connected to S1. So now current flows in this direction. So what happens is the pointer of the galvanometer will be deflected to the right like this. Okay, then current flows back into the S2, and then it is connected to the coil, and then the coil will move, current will flow in the coil back to DC, and it will move in a complete circle like that. Okay, what happens is now the induced current is reversed, and now you can see the current is negative. Okay, this is what happened in this position. Okay, now let us go back to this one. Okay, in this case, you can see that this is what we have discussed just now. You can see that the pointer of galvanometer is 0. So here is the value of induced current in this graph. It is 0. Now we go on to the next one. What happens in this case? Now the thing happens again. Now you can see it is still vertical. The difference is how the current flow. However, in this case, there's no current flow anymore, as I told you, because CD is moving parallel to magnetic field. It doesn't cut magnetic field. And AB here is moving in this direction, it doesn't cut the magnetic field also. So the pointer of galvanometer shows 0. That's why the induced current here is 0. Okay, that is the working principle of AC generator. And you can see more in the next video how the operation of AC generator. What is important here is we use 2 slip rings, but remember in DC motor we use split rings. This one is slip rings. Please don't be confused about this.